Hello, Godot Tutorials is not sponsored by or affiliated with the Godot game engine. You can also download the GitHub file project in the link in the description down below. Let's start with brute force coding. So in this case, we left off in the last episode with a game state, in this case menu, serve, play. However, our game doesn't really do anything. So let's go ahead and actually do something. So first, towards the bottom, I'm going to go ahead and create a variable for starting the player ball. So in this case, I went ahead and created a variable called ball speed, and I set it to 400 in the X direction and 0 on the Y. Next, let's actually go ahead and get our ball moving. So in this case, we want to head into our game state for play and actually move the ball. Now in this case, we're going to go ahead and change the position of our ball. So ball position, and we're just going to say plus equals ball speed. Keep in mind that this is a vector 2, and we're just going to multiply both the X and Y values by delta. Okay, so now that we have the ball moving, let's also make sure that we are actually updating our graphics to the scene, and we're just going to put update towards the bottom. Now if we go ahead and press play, you can see that our ball is actually moving. Next, let's go ahead and add collision checks to the side of our screen. So underneath here, I'm going to go ahead and add that code now. And basically, we're checking the left side of the screen. If our ball position is less than 0, we're going to go ahead and change our current state of the game. After changing the current state, we're also going to reset the delta key press. And then lastly, we're going to set the player serve. And that's because we need to change the direction of our ball. And basically, in this line of code, what we're saying is if our ball position has touched the edge, basically if the center of our ball has touched the edge, we're going to go ahead and change the current game state to serve state. We're going to go ahead, reset that delta key press to make sure that our player isn't pressing too quickly. And lastly, we're going to change the direction of the ball and make sure that if the opponent scored the point, it is the player serve and vice versa. And basically we can just go ahead and copy this for the AI, and we can just say if ball is greater than or equal to, and in this case we're going to say the screen width. Then we do everything again except we change this value to false. So is player serve is equal to false because the player scored the point and now the AI gets to serve. And we can check if this code works. And as you can see there, it worked. However, our ball hasn't reset its position. So let's go ahead and do that now. So in this case, we need to create two different variables, one for the ball position and one for the starting ball position. So on the top, you can see here, we already have the ball position. However, because we are changing this value, in order to reset it, we need to pass it in new values. So right now, because again, we're brute forcing our code, we're just going to go ahead and create a starting position value. We're going to go ahead and assign that starting ball position value into our ball position value. And now every time we change the ball position, we can simply just pass it in our starting ball position value to reset the ball position to the center of the screen. So in this case, let's go ahead and head back to our game state. In this case, we're going to go into the serve state. And at the very top, what I'm going to do is I'm going to just change the ball position back to the starting position. So ball position will be equal to starting position of our ball. And right here in our serve state, we ended up resetting the value of our position. And if we go ahead and test that out, you can see that as the game plays, it resets. However, the direction hasn't changed yet. So let's go ahead and actually change the code a little bit in order to change the direction based on which side of the screen the ball has made contact with. In this case, let's go ahead and actually add a new value. So right under the ball speed, we're going to go ahead and create a starting ball position speed. So similar as to what we did for the starting ball position. In this case, what we're going to do is just pass that in to the ball speed. So now we can change our ball speed and we can reset the starting position of our ball speed when the game ends, and we can change the direction by just adding a negative sign. So in this case, because we're dealing with the x-axis for our starting speed, in this case a speed of 400, we can say that the starting speed when the player is serving will go in the positive x direction, and when the player loses and the AI gets to serve, we add the negative and we move to the left. So let's go ahead and do that now. In this case, what we're going to do is head back to the serve state, and towards the bottom, we can actually change our direction. So let's make sure we change the direction before player input has set. And basically what we're saying is if it's the player's turn to serve, move the bow in the positive X direction and change the string to make sure that it shows to the player who is serving. And we can do the same thing if it's not the player's serve, and you can do that with the exclamation point. This flips the Boolean value, so in this case it turns false into true, so we can enter our if statement. And in this case, we can just add the negative sign and we can say AI serve. We can also get rid of this because we no longer need it. And so when we actually start our game and we press spacebar, you can see that it lets us know that it's the player's serve. And now because we scored a point, it's now the AI serve, and we can see that when it touches the end over here, what it does is it resets it back to the middle, and now we can go back and forth. And this is how we can use a little bit of states to change direction, to change what the game is doing, and so forth. Now, before moving on, I'm going to go ahead and change something. I accidentally misspelled position, so let me go ahead and fix that right now, and now we can move on. So in this case, we have our game moving back and forth when it hits the edge of the screen. However, it doesn't really do anything. We need to add collision between our ball and our paddles. So let's go ahead and add that. We can head back to the game state for play, and towards the bottom, we can actually add that code in. So let's go ahead and do that right now. Now in this case, let me explain quickly what's happening. First, we're taking our ball position on the X value. In this case, because it's a vector 2, it comes with both an X position and a Y position. We're taking the X position, we're subtracting ball radius because we want to make sure that this point is on the left side of the ball, and we're comparing that to basically our player paddles position. So in this case, player position.x, making sure that we are at least within range in the x-axis, and we're doing the same thing. We're making sure that this left point on our ball position is also less than the total size of the paddle, basically the width of our paddle. And we're testing the ball position on the y-axis, making sure that we are in between the player paddle's y-axis, and adding the paddle size to make sure that on the x-axis we're between the x width of our paddle, and on the y-axis we're between the height of our paddle. Then we take the inverse of the ball speed, and so the inverse is just the opposite of what it is, and by adding the negative sign, that is exactly what we are doing. We are inversing the ball speed. Now in this case, we can go ahead, copy paste this, and we can essentially do the same thing for the AI paddle. Now, because this is to the left of our ball, we need to use the plus sign to get this new position on the ball to the right side of the ball. And so now we have a right point on our ball, and we need to compare that to the AI position. And so we can just simply copy and paste that, go ahead, run our code, and when it runs, you'll notice that it actually reflects between the two paddles. Now in this case, this is great and all that we have this collision, but our game isn't doing anything really, especially for the player because they cannot move. So let's go ahead and create that. So first we're going to head over here, and just anywhere in the code, we're going to go ahead and actually create the player movement. So in this case, we can just call it player speed, and we can assign that a value of some sort, maybe in this case 300, but in my case I'm going to call it 200. Once that's done, we can head back to the game state in our play state, and towards the bottom we can actually add the code, and in this case it's just going to be a simple input is key pressed kind of thing, and we're going to make sure that we can move up or down. So in this case, if key W, because we want our player to move up, and I'm just going to pass in a simple pass. And then we can test again if our player is moving down. And in this case, the same thing is key pressed. However, for the scan code, we're going to say S. And in this case, I'm going to put pass. And basically what we're trying to do is if our player presses the W key, we move up. And if our player presses the S key, they move down. So let's go ahead and do that now. So in this case, we're just going to change the Y value of our player position. And in this case, player position.y. And we have to compound the speed. And in this case, since our player speed is a positive value, and because down grows in the positive value, to go up, we need to give a negative value. And so we can do that, passing in delta, of course. And we also need to change the player rectangle position. And in this case, we can just say rect2. And in this case, just say player position and paddle size. And that's it for the player position when we want to move up. And we can do the same thing when going down, but we just omit the negative sign. So now what we're saying is if we press W, we go up. We update our player rectangle so it makes sure that it draws properly to the screen. And so actually, if we go ahead and then run the game, I press up, I go up, I press down, I go down. However, two things. Our paddle goes beyond the game screen. I'll show you how to fix that later. And more importantly, our ball isn't really moving anywhere besides straight in a line. So as you saw there, our ball was moving left and right, and it really didn't change in direction. So I'm going to add some spaces because I'm going to work a little bit on this code. But basically, what we need to do is if it hits the top portion of our paddle, we move up. If it hits the middle of our paddle, we move straight. And if it hits the bottom portion of our paddle, we move at a downwards angle. Now, there are many ways to do this. However, I'm going to go take the route that, in my opinion, I think a beginner would do. And then towards the end of the episode, we'll take a look at perhaps a better way of implementing it further down an episode in this series. So what I'm going to do first is I'm going to test against the X position. And if the X position matches true, we're going to test against the Y position, different values of our Y position. And then based on which if statement, because I'm going to use if statements for this example, catches true, we're going to change the ball speed. And so let's go ahead and do that. So in this case, I'm going to get rid of that, add a parentheses, add that, and we're just going to move everything inside. I'm also going to add another if statement here, add the parentheses to make sure that we can actually press enter or an error throws. And basically what this does is it does the same exact thing. We aren't really doing anything differently. This still has the intended behavior. Basically, if we run the game, it's still going to collide. Nothing has really changed programmatically. What I do want to do is test against different if statements, and we're going to actually check that out right now. So first, I'm going to create a variable for paddle because I want to divide our paddle into equal sections. So in this case, 3 sections. And because we're doing it on the y-axis, we get the paddle size on the y-axis, divide that by 3, and we create this variable paddle that we can test against. So we need to add 3 if statements, one for each portion of the paddle that we're dividing with this 3 here. And what we're going to say is if ball player position.y starts at the top of our y position, and if ball position's y value is less than the starting position of our player position plus the paddle divide. Now, by adding the paddle position, what we're saying is the top portion of our player paddle, we want to do something, but we're moving straight here, and I don't really want that. And so I'm just going to create this temp ball position value, and I'm just going to call it vector2. And not only will this hold the ball speed on the x-axis, what we're going to do is we're going to actually go up by 400 pixels. And so we're going to have this angle. And then from this value, we're going to go ahead and pass that to our ball speed. Now, what we're saying with this if statement is if this expression is true, we're hitting the third or the top portion of our paddle, and we would like it to move upwards at an angle. We can actually copy and paste this and do several things with it. First, we need to change this into an else if statement. That way, if we fail the first expression, we move on to the second expression. If we fail the second expression, we move to the third expression, and so forth. And because we're dealing with paddle divides, we can actually multiply it. So multiply by 2, multiply by 3. We can change the values of the ball speed. In this case, what we're saying is if we hit the middle, we move our y-axis in a straight line. And lastly, we can get rid of the negative. And if we run this, what should happen is when the ball makes contact with our player paddle, we just move back and forth. And notice here, if I were to actually angle it up, it will go up. However, there's no collision at the top and bottom. And so we're going to work on that later, but let's test if it actually goes down, and there it is. Now we can do the same thing for the AI position. In this case, I'm just going to copy all of this. Just create 3 if statements. I'm actually going to borrow the variable paddle, bring that down here, and we can essentially do the same thing. We can actually just do that here. And we can actually take this value here and replace them all down here. And last but not least, we need to do the else if statement. So if we add the else if, normally I would not recommend writing your code like this because 1, it's not dynamic, and 2, lots of if statements are hard to maintain. And there are better solutions for changing the direction of our ball and making it dynamic. However, let's just go through this process as a beginner. And so for the first shot of writing the Pong game, this is actually really good because it actually shows that you're thinking about the game design in a way. Regardless, let's move on. So in this case, we need to add some type of collision between the top and the bottom. And so if we look at our code here, we can actually do that towards the top. And so I'm going to write it over here, and we're actually just going to test the ball position. So if ball position.y is subtracted by the ball radius, and we make sure that that is less than 0, then what we're doing is we're just going to change the direction. However, if our ball position on the y-axis plus the ball radius is greater than or equal to the screen height, what we do is we're going to invert the y-axis again, and that's actually pretty simple to do. All we're doing is we're just changing the y-axis and we're inverting it by the same value, and that's actually pretty simple to do. So now when we have our ball and it touches the top edge of the screen, we just invert the y value, and we do the same thing for the bottom, and that's where we get the bouncing effect. And so if we actually run this game, and we go ahead and actually move it, you can see that it starts bouncing. And when it reaches the edge of the screen, we actually change the direction that we serve. So basically, now that we've covered our collisions on the top and bottom portions of our screen, let's go ahead and actually have our AI paddle move towards the ball. And so a good place to put this code in is towards the bottom. And what we're going to say is basically if our AI position.y, we're basically just going to give it the ball position's y value. And of course, because we would like this centered, we're just going to call the y portion of our paddle size the height we want to give our paddle, divide that by 2. And now our AI position will be centered wherever the ball moves. Also keep in mind that because everything's inside the AI rectangle, in order to have this update properly, we need to pass in a new value to our AI rectangle. And we just call the new AI position followed by the paddle size. And now when we actually run the game, in the first half, our paddle's not going to move. But now, as the ball moves, we actually get. Now, as you can see here, as the ball keeps moving, our enemy AI is moving with the ball. And we're going to keep it like this to help us with coding later on, but basically, we have our game. And it reset itself. And that's because we're not really chasing the ball, we're just giving the player paddle the Y position of our ball. Now, there is a problem with our current code. Basically, our player paddle or our AI paddle can go beyond the player screen's height. Basically, if we move up or we move down, we can basically make our paddle disappear. And this is not what we intend for our player. So let's go ahead and use the clamp method from Godot to limit the player paddle and the AI paddle to the game screen. So clamping our values is fairly easy. The game engine provides us the clamp method. So in this case, what we say is we want to clamp our AI position. The first argument requires a value we wish to clamp our minimum and maximum values to. In this case, we're saying we would like to clamp the AI position.y value between 0.0, which is the top of our screen, and the screen height minus the paddle size on the y-axis. And when we run our game, what you should see is that our values are clamped to the game screen. So our paddle moves, but doesn't go beyond. However, we need to do the same thing for the player paddle. So let's go ahead and do that now. In this case, I'm just going to copy and paste this. We're actually going to put this in between here. We're going to change the AI position value, but we're going to keep everything the same. And now when we run our game, what happens is our player is going to be clamped to the screen. So as I'm pressing up, I don't go beyond. And as I press down, I don't go beyond the bottom. Now, whether or not you agree with where this is heading, at least our game is being built. And that's the most important thing, that the game is being built. And so our game looks almost complete. So let's go ahead and add some scoring. So towards the top, I'm going to go ahead and add some scoring. And in this case, we need some variables. One to hold the player score. And then we also need something to hold the player score text. And in this case, we can just say player score as a string, so we can convert our integer value into a string value. And we need some other things as well, so let me go ahead and do that. In this case, we need to calculate the width, the center of our string value, whether it be a single digit number or a double digit number. And lastly, we also need to make sure that we have the position of our player score text. Basically, we're doing the same thing we did for the top of the screen, but moving it towards the center on the left side for the player and the center on the right side for the opponent. In this case, we can just copy and paste that, give it new names, in this case, AI score and AI score text, and of course, AI text half width, and AI score position. And of course, we need to do one more thing. We need to make sure that we convert our AI score integer value into a string value, which we pass to the AI score text variable. Now that we have these values, let's go ahead and actually do something with it. In this case, display it to the screen. So when we head over to the ready virtual method, because we initialize our font data, and font size, we can actually go ahead and add these values to the screen. So in this case, let's go ahead and worry about the player text position. And we're actually just going to do the same thing. We're going to get the string size. And in this case, we want the player score text. And we're actually just going to worry about its x position, divide that by 2. And what we're saying is basically we get the width of our player text, divide that by 2. We get a value, which represents the middle. Then next, we get the player score position. We make sure that it's a vector 2 and that we have a half screen width. And we actually subtract that by the half screen width divided by 2. And then on top of that, we actually have to subtract the player text half width. And then we also get the font height, and we're going to add a little bit of padding, in this case 50 padding. In this case, what we do is we get the same thing for the text half width as well, and we can do the same thing. We get the string size. We make sure we pass in the score text, and then we divide that by 2 in order to get the middle position of our string, in this case, the player and enemy score. And then we get the score position, and we pass it in a vector 2, and we do the opposite actually of how we position the player. In this case, we do want the half screen width, but instead of subtracting, what we need to do is add it. And then we add it by another half screen width, divide that by 2. And again, the reason for that is if we add half by half, we're centering ourselves on the right side of the screen, but we also have to take into consideration the AI's half position, and we need to subtract it. And on top of that, we have a height font, and we're going to add 50. Now, lastly, what we need to do is we need to actually update all of this inside our draw method. And so far, our draw method is calling this set starting position function. And we will talk about that a little later. But regardless, we need to pass it in a font and a position and the value in which we wish to draw our string onto the screen. So in this case, what we're going to say is that we want our player score position and we want our player score text. And we can do the same thing for the bottom as well, our AI score position and the AI score text. And now when we run the game, you can see that our things actually appear, but they don't update. And that's because we need to actually add onto the values. Now, to change the values is quite simple. All we have to do is go into our collision for the left and right sides of our game screen, and that would be here. If ball position.x is less than 0 and ball position.x is greater than screen width, then we actually need to add our scores. And so in this case, if we're less than, then what that means is that our AI actually scored a point. We're going to compound the value of 1. And of course, we need to change our score.text. And we can just say AI score as string. Then we can also do the same thing for the other side of the screen. In this case, we say player score plus equals 1 and player score text will equal our player score as string. And now when we run this game, what we should see is that our score changes. And the same thing will be true for the AI if we are able to score a point against it. Now, next, let's go ahead and tackle the problem of the set starting position. Basically, we aren't resetting anything. And that's not good. We need to be able to reset things. We need to be able to reset it every time the player or opponent loses a point. And so let me go ahead and show you. As you can see here, if I move my player character towards the bottom, it should be centered. And the same thing for the enemy AI paddle as well. If I were to have it move, and as you can see, nothing has been centered. And when it's a serve, we should be able to reset everything. So let's go ahead and do that right now. Now, as you can see here, this doesn't really define what's happening. All we're doing is we're using this method to update everything inside. So let's go ahead and actually put this in here inside the draw method. That would be the most appropriate thing to do. So a function extract. And instead of having all this here, what we will do is actually reset the position of our AI, the position of our ball, and the position of our player. So let me go ahead and do that right now. We can start with the AI position. And of course, basically this code will look familiar to you because it's basically the same thing we did earlier in the series. Basically, we need to make sure that this goes inside our AI rectangle. So that is a rect2 data type. Pass in the newly established or resetted AI position and of course the paddle size. And we can do the same thing for the player position as well. And lastly, we can do the same thing for the starting position as well. So now that we have everything here, we can actually reset everything. So let me go ahead, copy paste this. If we go to the top, the most appropriate place to put it in is the serve. So let me go ahead and replace that right now. And on top of that, when we play the game, what happens is if something were to move, I get reset, player makes a score, and let me test me. And there we go, everything gets reset. And in a sense, we have a complete game, sort of. Basically, we need to do a few things. One is we need to give the player a chance to win. And two, we need some type of go, some type of endpoint. Basically, our game goes on forever, and that's just not okay. So in this case, let's go ahead and actually create some type of endpoint. So over here, in this case, let's create a constant, and we're going to call it max score. We're going to give this a value of 3. So our game ends when someone has reached 3. And we want to see who has won. So in this case, we're creating a Boolean value. Variable is player win, and it will either hold true or false. We're going to keep this empty. Now on top, we have this string value, which is displayed at the top of our screen. It says hello world. However, we're going to give some instructions. Start a game by pressing the space bar. Now what we're going to do is we're actually going to give good instructions to the player, because when they're in the menu screen, they have no clue how to get out of it. We made this game so we know we have to press the space bar, but the player playing your game has no clue. So in the menu, we're going to just get rid of this, change string, and when we run the game, you should see start a game by pressing the space bar. It could be better, but for now, this is a great start. However, what we're going to do is we're going to add some additional things. We're going to say if is player win, we actually want to do something. So let's make sure that we test for true. And then what we can say is we can actually change the string, and we can actually just let the player know that they won. So player wins. And then again, press spacebar to start a new game. And you can do the same thing for the value of false. So in this case, if player win is false, then it means the AI wins. And so we can congratulate the AI and press spacebar to start a new game. And if the player starts a new game, is player win is no, so it will not be true or false, and so this if statement will be passed. So you can either leave it as is, or you can turn it into an else if statement. Regardless, it will still have the same outcome when we press play. It will say start a game by pressing the play, player serve, and play the game. But that's not all. We need to do a little more. So let's go ahead and do that. So in this case, we need to make sure that when the game has finished, that we actually figure out who won and then reset all the scores after. So in this case, to manage player score, let's go ahead and do that in the serve state. And if max score is equal to player score, what we're going to do is we're going to end the game. And same thing here, if max score is equivalent to the AI score, basically whichever one reaches 3 wins the game, and we have to jump back to the menu state. So in this case, what we can do is actually say current game state will be equal to the game state of the menu screen, and we can do the same thing for the bottom as well. And we can just basically reset everything. So player score is 0, AI score becomes 0, and is player win is actually equal to true. And we can do the same thing for the bottom as well. So in this case, whether player wins or enemy wins, we go to the main state, we change our score to 0, and we make sure that we change the Boolean, in this case is player win state, to true or false. And actually the enemy AI should be false. Now lastly, when in the menu state, we wish the player to see the final score. However, we wish to change all that when we move into the serve state. And so up here, I'm going to add an update to force a call to the draw method. Now, our update doesn't really do anything because even though we change the player scores, we still need to change the text. So if we head to the menu state and in the input, we can actually change that. So in this case, player score text will equal player score as string. And we can do the same thing for score text of the AI as well. And now if we run our game, you can see that the AI wins. Press spacebar to start a new game. We can see the player score, but when we press spacebar, notice how we reset and everything looks good. Lastly, it's a little unfair that our enemy AI is perfect when chasing the ball. So let's go ahead and actually add a chasing AI effect instead of a perfect chasing AI effect. And if we head towards the bottom, this is our code here that positions our AI paddle perfectly to the ball. Instead, we want our AI to chase the ball's Y position. And so what we can say is if ball position.y is greater than AI position.y, and let's go ahead and add a buffer, because if we don't, you might notice some jittering. And so divide that by 2 plus 10, 10 being our buffer. What we say is that AI position.y plus equals a speed. In this case, our speed will be 250, and we pass in the delta time. Now, in this case, we can go ahead and copy and paste that as well, because we can just do the opposite direction. So if our ball is higher than the center of our ball position, making sure that we subtract 10 since we're moving up, then we can say that our AI will have a negative speed. Now, as you can see here, our enemy paddle is actually chasing the ball except when it reaches the buffer zone. Now, if we keep doing this, what we'll see is eventually we should be able to win. And as you can see here, we do have the ability to win. Player wins, press play bar, AI serve, and play. And that's the great thing. The way we wrote our code, basically whoever lost in the last match gets to go first. What I'm going to do is I'm going to go ahead and clean up some of the code. So in this case, player serve, press spacebar to start, or excuse me, in this case to serve. And we're going to actually do the same thing for the AI string as well. And that's basically it. So ask yourself this question. Based on the code that we've written so far, is our code maintainable and is our code readable? And with the techniques I showed you in previous episodes, you should be able to come out to a conclusion. But that's not to take away from what we've done so far, especially if you're a beginner. If this is the kind of code you've written, believe it or not, this is amazing because we actually got something done. We actually have a menu state, we have a serve state, and then lastly, we actually have the gameplay state where we actually chase the ball. On top of that, we have a basic AI to play against. It's not the most perfect AI, but it's something. It's a step above creating a second player. But regardless, this code that we've written is not good enough to show off when doing an interview, because keep in mind that the goal of our project was to show off during an interview, to use this inside of our portfolio that we're proud enough to submit with a resume. So in the next episode, let's go ahead and take a look at how we can tackle at creating a better game. Well, thank you for subscribing and thank you for clicking the like button. I look forward to seeing you in the next episode. Have an amazing day.